The next point, we should ensure whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
Good day, learners. You are welcome to Kaduna State's Ministry of Education Radio, Television, e-learning program. I am Sadiq Dalhatu Jae, standing here to teach mathematics. Our topic is named variation, and the subtopic is types of variation. And our discussion will be specifically on direct variation. First, let's see the introductory aspect of variation. We said the word variation, or simply proportion, is used to describe the relationship which exists between two or more quantities. And in mathematics, we usually deal with only two quantities. The first one is variable quantities, known as variable, or constant quantities, known as the constants. If the value of a quantity remain unaltered or unchanged, then we said the variable is, the quantity is constant. And if under certain situation, the variable or the quantity changes, then it is referred to as variable. As I said earlier, if the value of a quantity remain unchanged, then that is referred to as constant. But under certain situation, if the value changes, then it is not a constant, rather it is referred to as a variable. For example, 22/7, which is the value of pi, and the acceleration due to gravity, which is given as 10 meters per second square, these values are always constant. They will not change, and they never change. But in a situation where we set a speed of a car, demand of commodities, or a population of a town, these are variables because they are subject to change. And this can be best explained using a simple equation which is given as y equals to mx, where m is our constant. In this equation, y and x are variables. It is only m that is our constant, which means the value of m will never change, but y and x can change. And if we assume that the value of m is 5, then our equation will now change to y equals to 5x. Reason because we set the value of m to be 5. Then what will happen if the value of x is 1? Now the equation will be y equals to 5 times 1, because we said the value of x is 1. And when we have 5 times 1 is 5. That is, we have y equals to 5. Then when x equals to 2, this equation will change to y equals to 2 times 5. 5 is the value of m, which is a constant, and 2 is the value of x. Having y equals to 2 times 5, 2 times 5 is 10. What this simple equation is saying, as the value of x changes, likewise the values of y will also change. Let's take another one. What about if the value of x is 3? Then the equation will be y equals to 5 times 3, and this will give us 15. Therefore, in general, as the value of x keep on changing, likewise the value of y will also change. Variation can be of different types according to the pattern of changing or relationship with variables. The following are types of variations that do exist. A, direct variation. B, inverse or indirect variation. C, joint variation. And D is partial variation. As I said earlier, our focus today is only on direct variation. Let's see what is direct variation. We said in a variation, if variable changes proportionately, that is, either increase or decrease together, then it is called direct variation. If x is in direct variation with y, it can be symbolically written as x is proportional to y. In general, if you want to understand the basic of direct variation, what should come to your mind? For example, each student needs a textbook. Therefore, as the number of students increase, the number of textbooks will also increase. Therefore, these two variables are increasing together. If the number of students decrease, then the amount of textbooks will also decrease. That is why we said if the variables increase or decrease together, then it is a direct variation. Let's see examples. The first example, that is example 1, we said y varies directly as the square of x. If y equals to 98, when x equals to 7, calculates y when x equals to 5. The question again. Y varies directly as the square of x. If y equals to 98, when x equals to 7, calculates y when x equals to 5. Solution, we are under direct variation, so the statement can be mathematically represented as y is proportional to x squared. That is a sign of proportionality. Then, to remove proportionality sign, you must introduce a constant. Therefore, this can be written as y equals to kx squared, where k is our constant. Remember from the question, the value of y is 98, while the value of x is 7. Upon substitution, we have 98 equals to k 7 raised to the power of 2. We have 98 equals to k 7 raised to the power of 2. 7 raised to the power of 2 is 7 times 7, which is going to give us 49. That is 98 equals to 49k. When we divide both sides by the coefficient of k, which is 49, then we have 98 over 49 equals to 49k over 49. From the right-hand side of this equation, 49 at the denominator will cancel 49 at the numerator, and 98 divided by 49 is 2. Therefore, the value of k, which is our constant, is 2. Then the question says we find the value of y when x equals to 5. So we are going to substitute the values of k and x, which is 5, in the equation y equals to kx squared. Therefore, upon substitution, we have y equals to 2, open bracket, 5 squared, bracket close. 5 squared is 5 times 5, which is the same thing as 25. Therefore, we have y equals to 2 times 25. And 2 times 25 is 50. Therefore, the value of y when x equals to 5 is 50, which is the final answer of example 1. let's see the second example, which is example 2. If x is directly proportional to y and x equals to 20 when y equals to x, find A, the formula connecting x and y. B, find x when y equals to 7. C, find y when x equals to 10. Let's see the solution. A, x is proportional to y from the question. Then, as I said earlier in example 1, for you to remove proportionality sign, you must introduce a constant. Therefore, this can be written as x equals to ky, where k is constant. And from the question, the value of x is 20 and the value of y is 8. Now we substitute 20 for x and 8 for y. Therefore, we have 20 equals to 8k. Dividing both sides by the coefficient of k, which is 8, then we have 20 over 8 equals to 8k over 8. From the right-hand side of this equation, 8 will cancel 8, and you will be left with k equals to 5 over 2, because 20 divided by 8 is 5 over 2. Therefore, the value of our constant, which is k, is 5 over 2. Now, the first question says we should find the formula connecting x and y. All you need to do, you go back to the first equation, which is x equals to ky, and substitute the value of k, which is 5 over 2. Therefore, we have x equals to 5 over 2y. And x equals to 5 over 2y is the formula connecting x and y. Learners should take note. In other questions, you may not ask to find the formula connecting x and y, but the relationship between x and y. These two things are used interchangeably, either to find the formula connecting x and y or to find the relationship between x and y. Sometimes the laws connecting x and y, that is the two variables. Then B part of the question, we are to find the value of x when y equals to 7. When y equals to 7, then what will happen to that equation? Remember, the equation is x equals to 5 over 2y. Now you substitute the value of y, which is 7, in the equation. That is, we have x equals to 5 over 2 times y. Upon multiplication, 5 times 7 is 35. So we have x equals to 35 over 2. And this can be expressed as 17 whole number 1 over 2. Then C part of the question, we are to find the value of y when x equals to 10. The same thing, you go back to the formula x equals to 5 over 2y and substitute 10 for x. That is, 10 equals to 5 over 2y. Multiplying both sides by 2, we have 2 times 10 equals to 5 over 2y times 2. And 2 times 10 is 20. 2 at the numerator will cancel 2. And we'll be left with 5y. Therefore, our new equation will be 20 equals to 5y. Dividing both sides by the coefficient of y, which is 5, then we have 20 over 5 equals to 5y over 5. From the right-hand side of this equation, 5 at the numerator will cancel 5 at the denominator. 20 divided by 5 is 4. Therefore, the final answer, which is the value of y when x, the value of y when x equals to 10 is 4. Our final result there is y equals to 4, which is the final answer. Example 3, and the question says, if p plus 3 is directly proportional to the square of q, and p equals to 5, when q equals to 2, find A, the relationship between p and q. B, you find p when q equals to 6. The question again, if p plus 3 is directly proportional to the square of p of q, and p equals to 5 when q equals to 2, find A, the relationship between p and q. B, you find the value of p when q equals to 6. Let's see the solution. The solution A, which is the relationship between p and q. First, we have p plus 3 in bracket is directly proportional to q squared, because from the question it says p plus 3 is directly proportional to the square of q. Here, q has a square. Then for you to remove proportionality sign, you have to introduce a constant. Then we have p plus 3 equals to mq squared, where m is the constant. Then p plus 3 equals to mq squared. Remember from the question, the value of p is 5 and the value of q is 2. Upon substitution, we have 5 plus 3 equals to m squared. Reason, because q is, from the question we said q squared. That is the reason why we substitute 2 for q and we have squared there. And 2 squared, it simply means 2 times 2. 2 times 2 will give us 4. And 5 plus 3 is the same thing as 8. Therefore, the equation will be 8 equals to 4m. When we divide both sides by the coefficient of m, which is 4, we have 8 over 4 equals to 4m over 4. Looking at the right-hand side of this equation, we have 4 at the numerator and we also have 4 at the denominator. Therefore, 4 will cancel 4. And 8 divided by 4 is 2. Therefore, the value of m, which is our constant, is 2. Hence, we go back to the original equation, which is p plus 3 equals to 2q squared, and substitute the value of our constant, which is m, that is 2. We have p plus 3 equals to 2q squared. And p plus 3 equals to 2q squared is the relationship that exists between p and q, or it is the formula connecting p and q, or it is the law connecting p and q. B part of the question says we find the value of P when Q equals to 6. And when Q equals to 6, all you need to do is to substitute the value of Q, which is 6, from the given equation. P plus 3 equals to 2Q squared. Therefore, P plus 3 equals to 2, open bracket, 6, bracket close, squared. When you have 6 squared means 6 times 6. And 6 times 6 is the same thing as 36. Therefore, the next step will be P plus 3 equals to 2 times 36. And 2 times 36 is 72. Therefore, P plus 3 equals to 72. When positive 3, that is plus 3, cross the equality sign to the right-hand side of the equation, the sign, that is the positive sign, which is plus, will now change to negative. Then we have P equals to 72 minus 3. And 72 minus 3 is 69. Therefore, the value of P when Q equals to 6 is 69. To end this lesson, I have an assignment for you. And the question says, if Y varies directly as the cube of X and Y equals to 6, when X equals to 4, find A, the formula connecting X and Y. B, find Y when X equals to 16. C, find X when Y equals to 3. The question again. If Y varies directly as the cube of X and Y equals to 6, when X equals to 4, find A, the formula connecting X and Y. B, find Y when X equals to 16. C, find X when Y equals to 3. I remain Sadiq Al-Hatujae. For further explanation, comment or suggestion, you can contact me via the following numbers: 080 62 26 43 36. The number again, 080 62 26 43 36. Stay home, stay safe, and keep learning.